Now, I guarantee you that I'm going to ask you for this definition on your first test. Because it is the foundation, basically, of calculus. All right. Now, in your books, let's see where they stick it. It's on page 76. All right, it's on page 76 in your books. Now, the limit of f of x as x approaches c equals L. All right. Okay. So if the limit of f of x as x approaches c equals L, then for every epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus c is less than delta, all right, but bigger than 0, then the absolute value of f of x minus L is less than epsilon. So you write that down, and then I'm going to try to explain to you what that means. Now, this is one of the reasons that absolute value was on your review sheet. This definition would show up eventually. Okay? All right. Look what happens. Now I'm going to erase this for a second, and I'll put it back in a minute. All right, remember what we said about absolute value. The absolute value I'll open it back in a second so we don't die. All right, now. Remember there were two cases with absolute value. All right. So either x minus c is less than delta. Remember the first time you just drop the bars. Okay. The next time you drop the bars, I can drop them. All right. And then you reverse that, and then you change the sign on that, and my connector word is and. So x minus c is smaller than delta. All right. And x minus c is bigger than the negative delta. So do you understand that this is a way to write both of those at the same time? When you write something like that, it means and. So that says that x minus c is smaller than delta, and this one says x minus c is bigger than the negative delta. So this means this. Okay. Now, suppose I've got some function. All right, let's just call it f of x. All right. When you see epsilons and deltas in math, normally they stand for really small values. Okay? So here's what this is saying. Now, if I want to solve this for x, wouldn't I have to add a c right now? Wouldn't I have to add c? But if I add c here, what do I got to do here and here? I've also got to do what? Add a c. So I'm going to get like a negative delta plus c is less than x is less than delta plus c. Now I'm going to kind of rearrange it a little bit. Because addition is commutative, right? Changing the order doesn't change the answer. Instead of putting negative delta plus C, isn't that the same thing as C minus delta? So look what this says. Your X value's got to be between C plus a little bit and C what? Minus a little bit. So that means like if I'm over here, I'm going to take this C and I'm going to add a little bit. And I'm going to take that C and subtract that same amount, subtract that little bit. So my X values have to stay but in that little interval. C plus a little bit and C what? Minus a little bit. All right, similarly, this is the same thing. This tells me, a different color. This says that f of x minus L is going to be smaller than epsilon. It's going to be bigger than the negative epsilon. And again, if I want to solve for f of x, wouldn't I have to add L here? Which means I've got to add L where? All the way across. So I've got a negative epsilon plus L, and I've got an epsilon plus L. All right, and again, I was going to arrange it because it makes a little more sense and put L plus epsilon, because most of us don't think of a negative epsilon plus L. We think of it as L what? Minus epsilon. And again, epsilon is just a small number. So that would be L plus a little bit. And that would be L minus a little bit. So here's what it's saying. On this picture, they're saying that the limit of your function as x approaches C, they're saying they think that's L. I think it's this Y value. Well, for that to be true, here's what it means. For every epsilon greater than 0. Now, every time you tell me I've got to stay this close to L, I've got to be able to find some delta between here and here, basically, that will put me in that box. And it's got to work every single time. Now, let me kind of show you what I'm talking about with numbers, and then we'll kind of do it abstractly. All right, I'm sure that you did not do this because you're better than me. All right. When I was in high school and I had to go in the lab sometimes, I was pretty good at math. So a lot of times I would mathematically figure out what I was supposed to find out in lab. And then magically, my data fit that with a little error. You see what I'm saying? Because if it's perfect, it's not going to look good, is it? So do you understand? I didn't do it the way it was intended to be. Instead of going from like this and figuring this out, I went from the figuring out down to this. Everybody with me? It's called working backwards. All right, you do it a lot of times when you look to the back of the book. You look at the answer, then what do? Try to work back and get it. All right, so here's what I'm talking about. I'm going to erase this for a second. All right, this part right here. All right. Now, what if I told you this? What if I told you that you had some function, f of x, that was something like 2x plus 1? Right, that's just a little line. And you tell me that you think that this is true. You think the limit on that function as x approaches, let's just do something simple, 3 is 7. That's what you've decided. And you tell me that I have to prove that. Well, here's what has to happen. Now look what it says. For every epsilon greater than 0, you got to be able to find a delta. Now, what does that mean? All right, let's go back to what we said. Remember we said, what does this mean? This means that f of x has to stay between what? L minus epsilon and what? L what? Plus epsilon. So here's what you tell me. Epsilon is going to be 0.5. It's going to be a half. So I've got to figure out some delta that will make this work every time. Now, what's my f of x in this problem? Look where the position of f of x is. Is it after limit? What's my function in this problem? 2x plus 1. It's got to stay between L minus epsilon. Now, what do you, look at the position again. What do you guess the limit is? For some reason, you guess the limit is what? 7. Minus epsilon. And L, your guess of L plus what? Epsilon. Well, for that to be true, 2x plus 1 would have to stay between 7 and 5/10 and what? 6 and 5/10. Now, I'm going to solve this for x. If I don't lose my 1, how can I get rid of that plus 1? Subtract 1 all the way across, right? So what's that going to put 2x between? Instead of 6.5, it's going to be what? 5.5. Instead of 7.5, it's going to be. So does everybody understand I subtracted 1 here, here, and here to get my 2x? All right, get your calculators out. You probably do it in your head, but now I'm trying to solve for x, correct? How am I going to get rid of that 2? I'm going to have to divide everything by 2. All right, what's 5 and 5/10 when you half it? What do you get? 2.75. Now, what's 6 and 5/10 when you have it? 3 point what? Now, go back to this for a second. Doesn't that say that x minus c, did we say that had to be between what? Delta and negative delta, remember? So x had to be between c minus delta and c what? Plus delta. Now, look where c is. You see c is this number? What's my c down here? 3. Now, look at this form right here and look at this form right here. If I keep x between 2.75 and 3.25, wouldn't that force this y value to stay between 6.5 and what? 7.5. So you chose epsilon to be 0.5. Now I kind of worked backwards. As long as I keep my x between these two numbers, I can do what you asked me to and keep my y between those two numbers. Now, what is c in this problem? Look where the c is and look down here. What's my c? 3. So this number has to be 3 plus something to get the same form, right? And this number is 3 minus something. What's my something? Okay, then I'm going to let delta be 0.25. Problem solved. If you want me to keep my y values, let me throw that at you, Helen. If you want me to keep my y values between 6.5 and 5.5, it's not a problem. I figured out I can do that as long as I choose delta to be 0.25. Problem, I can do it. But it doesn't have to work just once. It's got to work for what? Every time you do it. So look what happens. In other words, you want me to keep my y values here? Okay, I had to figure out how far to widen or shrink this to do it. What if you change this number right here? Then I'm going to change that number. So what if you decide to shrink from epsilon to be 0.5? What if you say, I'm going to make it harder. I'm going to squeeze this tighter. Okay? What if you decide to let epsilon be 0.1? Well, if you let epsilon be 1/10, I've got to find some delta that does that, right? Just going to work it again. Now, I still want 2x plus 1 to be between, if my guess is 7, I've got to have 7 plus a little bit and 7 what? Minus a little bit. What's my little bit this time, though? It's not 0.5, it's what? 0.1. So now I've got to keep it not between 7.5 and 6.5. What if I got to keep my y values between? 7 point what? 1 and 6 point what? 9, isn't it? Okay, well, let me ask you this. If I subtract 1 all the way across, what's that going to turn this one into? Isn't that going to be 6 1/10? If I subtract 1 over here, what's it going to turn that one into? 5 and what? Now again, how are you going to get rid of that 2? All right, you got a calculator. Divide 6 1/10 by 2 and tell me what I get. 3 point what? 05. If you take 5 9/10 and half it, what do I get? 2 point what? 95. Now again, I've got to make it fit this form. That's 3 plus a little bit and 3 what? Minus a little bit. Well, what must be the little bit? It is easier to look at the addition to me than the subtraction. Wouldn't my epsilon have to be, my delta have to be 0.0 what? 0.05. Now, I'm going to do one more and let you work it. What if you say, okay, I'm going to make it really hard. I want epsilon to be 0.002. So it's a tiny little number. Go find me what delta will do that.
For the 2 examples you have, they're like, you can like times the epsilon times 2. Is that just not a?
In other words, you're looking for a pattern. Yeah. What's my function? We agreed my function's what? What's my f of x? 2x plus 1, right? Now, what are we guessing that L is? They told me that they're guessing L is what? 7. Now, what did I tell you epsilon was this time? 2,000? So I've got to subtract that 2,000 and I've got to add that what? 2,000. So that means 2x plus 1 is going to have to stay between 7 and 2 what? Thousandths. And what's this going to be? 6.99 what? 8. Everybody okay? Now, how am I going to solve that for x? What have I got to do all the way across? I'm going to subtract 1 here, so I got to subtract 1 there, and I got to subtract 1 there. Everybody okay? So the ones in the middle go out and leave me 2x. Okay? What's 6 and 998 thousandths minus 1? It's going to be what? Are they going to be 5 and 998 thousandths? And then what's this number gonna be? 6 and what? 2,000? Now, how am I gonna solve that for x? So if I divide this side by 2, what do I gotta do all the way across? Divide everything by 2. All right. So x comes out to be, now when you take this number and half it, don't you get 3.001? What happens when you have this? What are you gonna get? 2 point what? 999?
Wait.
That's,
Is that right? Is it 9 or, is that right?
Yeah.
Okay, now, remember, I'm trying to make it fit this form. I need x between 3 plus something and 3 what? Minus something. Now, it's got to be the same something. You can't like add 2 over here and subtract 4 over here. Is everybody with me? I think I do better adding in my head than subtracting. So, what is this? 3 plus what? 0.001. Now try this over here. Is this 3 minus 0.001?
Yes.
Yeah. So for this to be true, what would delta have to be? It have to be point what?
0.001.
Now here's what Storm was asking. I want you to see if you can find a pattern. When epsilon was 0.5, it's half. Is everybody with me? Now you can, in other words, it's half or smaller. In other words, if it stays in the box here, it stays in the box there. Is everybody with me? In other words, you're finding now, look what happens. This was an easy pattern to see. When epsilon is 0.5, delta came out to be 0.25. When epsilon was 0.1, delta came out to be 0.05. When epsilon was 0.002, delta came out to be what? 0.001. So that means when you tell me any epsilon, you can just pick one out of the air. I know how to get a delta. What am I going to do to the number you give me? I'm going to half it. And I can half any number with the calculator. Everybody with me? Maybe not in my head, but I'm good to go. So that means for every epsilon that you give me, there's not one I can't find a delta that works. Now, the problem with doing it this way is twofold. One is that was an easy pattern to see. It'd be different if every epsilon I need to multiply by 5 11s. I doubt you're going to see that pattern. Is everybody with me? And the other is because this pattern was easy, after 3 tries, I figured out the pattern. When the patterns get more complicated, you may have to do this problem 30 times before you figure out the patterns. Everybody with me? I ain't got time for that. So what I'm going to do is I'm going to do it abstractly. And then I'm going to turn it into a proof. Now, people freak out sometimes when we do things abstractly. All right? We're not going to freak out. Abstractly is way better than concretely a lot of times. Because it's hard for me to divide 5 and 998 thousandths by 2 in my head. Is everybody with me? But dividing like 2x plus 4 by 2 in my head is not a big deal. So a lot of times variables make things easier, not harder. Now here's what I mean. But notice what I did. I had to go from this form to this form. Is everybody with me? So I had to go from f of x in the middle to what? X in the middle. That's your goal. Everybody okay? All right, so let me show you what I mean. Prove that the limit of 2x plus 1 as x approaches 3 is 7. Now, prove is a bold statement. Now, look what has to be true for me to do this. That theorem said I had to find, for every epsilon, there had to be a delta, right? Such that if the absolute value of x minus c was less than delta. Is everybody with me? Now there's a 0 here. I'll talk about that in a minute. I'm gonna leave it off for a second. Then the absolute value of f of x minus L is less than epsilon. I mean, isn't that the definition of what it said? If this is true, then what? This is true. Now, the best thing about this proof is it tells you the beginning and it tells you the answer. All you got to do is fill in the what? The middle. Now, here's what's always going to happen in your books when you're looking in your book. It looks like magic. They go in here and go, okay, x minus, now look up here at your form. What up there is your C? 3. So all they did was fill in their C's. Everybody with me? Then all of a sudden in your book it says choose delta equal to something. And you're like, well, how did you know what to choose? Because they did what I did. I'm going to go over here and I'm going to do some scratch work. I'm back in lab. I'm going to start with the answer and work backwards to the problem. So instead of starting with this and ending with this, guess what I'm about to do over there where nobody sees? I'm going to start with what? This. And try to get back to what? To that. All right. So instead of going the way they want me to go, I'm going what? Backwards. Now, let's fill in what we know first. Do we know what f of x is in this problem? Look up here at your form. What's your function? What's your f of x? 2x plus 1. All right. What are they claiming that your L is? What's your limit? They're claiming it's what? 7. So all I did was go fill in my particular numbers on this problem. Is everybody with me? Now jump down here for a second. What's your C in this problem? 3. Now, look at what your goal is. I've got to use legitimate math and turn this into this. Well, what's one thing I see I can do to make it look a little bit better? All right, so combine that for me. What's 1 minus 7? Minus 6. We okay? Now, I don't want 2x minus 6. I'm trying to get what? X minus 3. What do you notice I can do that's going to be super helpful here? Now, you got to follow math. Everybody with me? You can't just go ripping things out of absolute value bars unless you can explain to me how you know that. I'm going to factor a 2 out, and what's going to show up all of a sudden? X what? Minus 3. We agree? Now, there's a theorem in algebra that says this. The absolute value of AB is the absolute value of A times the absolute value of B. I'm about to use that kind of backwards. I'm going to take this one thing and split it into 2 things. Everybody with me? So that's the absolute value of 2 times what? The absolute value of what? X minus 3. I'm going to drop mine a little bit because I'm running out of room. Now, what's the absolute value of 2? 2. We agree? Now, I don't want 2 times the absolute value of x minus 3. I just want the absolute value of what? X minus 3. So how am I going to get rid of that 2? Divide by it. Now, look at this and look at this. When are these two going to be identical? If delta's what? Epsilon over 2. As long as delta's epsilon over 2, this works, right? So guess what I'm going to choose delta to be over here? Epsilon over what? 2. Now, the book doesn't show any of this. All of a sudden, it looks like that the 10 Commandments came down and then Moses was handed this. Is everybody with me? But he wasn't. Now, to do the proof, all I'm really going to do is take this and copy it what? Backwards. And you do that all the freaking time. Because you check the answer on the back and you work backwards and I never see it. It looks like you just knew straight what to do. That's what you're doing here. If I choose delta to be epsilon over 2, what does this turn into? Then the absolute value of x minus 3 is less than what? If you choose delta to be that, then can't you replace delta with that? Now, what am I trying to get down to? I'm going to drop it. So I got a little more room. Same thing. In this particular problem, wasn't your f of x 2x what? Plus 1? Minus, what's your L? Wasn't it 7? Now, how do I get from this to this? Well, look over here. And just copy the thing backwards. So, what am I going to do next to get from here to here? Aren't you going to multiply both sides by 2? Everybody okay? So what's that 2 and that 2 going to do? Aren't they going to go out and leave you epsilon? Now, what happens next? What am I going to replace 2 with? Isn't 2 the same thing as the absolute value of 2? So all I did was replace something. 2 and the absolute value of 2 are mathematically the same. Now, do you see that I'm about to take this property and reverse it? The absolute value of one thing times the absolute value of the other thing is the absolute value of their product. See, I'm just reversing it. Then what am I going to do? I'm going to multiply it out, am I not? So that's going to give me 2x minus 6 is less than epsilon. Now, there are 1,000 ways to write 2x minus 6. I'm going to choose to write it as plus 1 what? Minus 7, not minus 1 minus 5, and not, you know, why am I choosing that? Because I need it to be in the form f of x minus what? L. So I have started where they told me. If this is true, as long as I choose my delta to be half of your epsilon, I can always end up where I need to be. So this is the proof on the left side. Now, if you do it for me on a test, I want you to leave your scratch work over there. Now, it won't always be in every problem epsilon divided by 2. It might be 3 times epsilon sometimes. It might be epsilon divided by 7 sometimes. You should say it can change. But you're supposed to start with this one and end with this one. We're just going to kind of work backwards so we know what, because the first thing they really do is they choose delta equal to something. And it looks like they just knew by glancing what to let it be, but they didn't. They did all that scratch work over there. Okay? So I'm going to give you a couple for homework, and we'll say do a proof. And this is what I'm talking about. You've got to start with this one, and you've got to end with that one. Now, that takes a long time, and these are just linear functions. When you start getting quadratics and cubes, these proofs get nasty in a hurry. But this is a freshman level class, so all you're doing is the simplest kind of little proof just to get you used to doing proofs, okay? Now, so that we don't have to keep doing this over and over, we're gonna go get some properties. Okay, but for homework, you're gonna have to do one like this. Is everybody with me? Now, the other thing let me warn you about is this. Depending on you take Cal 2 and who you have. I've warned you before somewhat that math has its own language. So a lot of times, if I'm in Cal 2 and I go to write down the definition of a limit, I put a lot of symbols and not a lot of words. It will be something like this. The limit of f of x as x approaches c equals L if and only if now, that little funny looking upside down capital A stands for every. So instead of writing the words for every, a mathematician will put that symbol. Epsilon greater than 0, that backwards looking capital E stands for the phrase there exists. And that funny looking sideways curvy E stands for such that. But don't be intimidated by symbols. That's just shorthand notation that mathematicians will use because like I told you before, I can go pick up a math journal and that's the same symbol in any language in math. That's the same symbols. Everybody with me? But for purposes, I'm going to write it out in words. Now, see, here's what would happen if you didn't have a limit. Do we agree that if you were trying to get close to C from this side, you'd be getting something close to that number? Is everybody with me? But when you're trying to get close to C from this side, you're never going to get anything down here, are you? And the reason is, see, when I tell you that you got to stay this close, I can't find an interval here that's going to do that. Because if I try to do the interval here, the graph is way up here. It's not in my box. Is everybody with me? I can't make a box so that the y value stays in it at this jump. So that's why that limit's not going to exist. See here, when you shrink this and I shrink this, or when you expand that and I expand that, I can stay, my y values can stay what? In that box. But when you don't have a limit, you can't make a box that it stays in. All right? Now, let's go get some theorems so we don't have to keep doing this over and over and over and over. Now, I'm going to give you what you might think of as some longer limit rules, but you're going to need to know them for us to do something later. All right? Wednesday, I'll give you some shortcut rules. All right, but for tonight, you're going to be doing proofs and using kind of the longer rules. All right, so these are kind of your limit properties. So these are based on the definition that I just gave. Okay, so these help us not to have to use that definition over and over and over again. All right, here's the first one. The limit of, let's see what letter your book's going to use. B. All right, you write that down, and I'm going to write some notes under it. This B is a number. Here's what I'm talking about. Example. The limit of 4 as x approaches 1 is. Now, look at the form. Do you see that your B here is a 4? Then according to this rule, what should your answer be? 4. The limit of a constant is that constant. Now, I want you to think about why that has to be true. What's your function right here? Think about your form. What's your f of x in this problem? What's your f of x in this problem? Isn't it 4? Now, what's f of x the same thing as? What can you replace f of x with? All right. What does the graph y equals 4 look like? Horizontal or vertical? Horizontal, right? That's the graph y, or f of x equals 4. When you're getting close to, say, 1 from the left side, what's your y value getting close to? Well, actually, it's not getting close to anything. It is what? 4. What if you were over here? What's your y value still? 4. What if you were over here, like approaching like 29? What's your y value always on this graph? 4. So since your y value everywhere on the graph is this number, your limit's always going to be what? That same what? Number. It wouldn't matter what it didn't matter what that number is right there. It could be x approaching negative square root of 11. It doesn't matter. The limit of a constant is that what? Constant. And that's what? Does that make sense? All right, look at this one. Black, so it kind of matches. The limit as x approaches c, okay, of x is c. So example, what's the limit of x as x approaches 5? According to this, what's it going to be? Now you write that down and let me explain it to you from the graph. Now back over here again, look at your position. What's your f of x in this example? What's your f of x right here? X. Now remind me again, what's f of x the same thing as? All right, what does y equals x look like when you graph it? Isn't that a line? Which quadrant does it split? 1 and 3, right? Now, what points are on that line? Give me a point that's on that line. 1, 1. What's another one? 0, 0. Give me another one. 3, 3. About negative square root of 17.
Negative square root of 17.
You with me? So on that graph, what about the x's and y coordinates? They're always what? The same. So if x is getting close to 5, what's y going to have to be getting close to? 5. If x was getting close to a negative 3, what would y be getting close to on that picture? Negative 3. Because on that picture, x's and y's are always what? The same. We okay so far? All right. Let me see what variable you're most going to use. Let's do it this way. Oh, I wrote it backwards. X approaches C. Let me show you what I mean by that. what's my function on this graph? What's my f of x on this example? X squared. So y equals what? X squared. So that'd be like a parabola, wouldn't it? All right, give me some points on that parabola. 0, 0. What's another one? 2 what? 4. 3 what? -1 what? 1. How do you know when I give you the x, what are you doing to get the y? Squaring it. So what if I tell you that your x is getting close to 5? What do you think your y is going to be getting close to? 25. So on this graph, when x is getting close to 3, what are you expecting y to be getting close to? 3 what? Squared, which is what? 9. Now, the reason it says an n up here, what if I gave you this? What's happening on this graph? What's your function on this graph? It's not x squared, it's what? X cubed, isn't it? Isn't that like an S curve? So what if x is getting close to 10 on that picture? What would you think the y would be getting close to? 1,000, wouldn't it? Because what do you do to get the y value? You take the x value and you what? You cube it. So on this picture, when x is getting close to 2 on this S curve, what are you expecting your y to be getting close to? 2 cubed, which is what? So it doesn't have to be just a square, it can be any power. Is everybody with me? So if this is getting squared, your number is going to get what? Squared. If this is cubed, then your number is going to get what? Cubed. If it's to the 5th power, your number is going to go to what? The 5th power. So do you really see that this one is a special case of this one? Because here your power is just a what? A 1. Is everybody with me? And so you get c to the 1. So this to me is kind of a waste. It's just you see this one more than you see that one. So they wrote it separately. Now, there are a couple of others that come in pretty handy, and here's one of them. The limit of b times f of x as x approaches c is b times the limit of f of x as x approaches c. Now, b is a number, just like up here. Now look what it's giving me permission to do. It's giving me permission to take this b and pull it out front. Is everybody with me? So I can change the order. Instead of multiplying the function by a number and then taking the limit, it's letting me take the limit of the function and then multiply by the number. Now, why is that important? Because that would be a problem like this. Now, do you see, I'm looking at, these are the only 4 theorems I have, so I can only use these. When I get more theorems, I can do this multiple ways. I have something to a power, but I don't have anything in front of it. So this looks a lot like number 3, but not exactly. What's messing me up? What's messing me up is the what? 4. The 4. But this one gives me permission to take that 4 and do what? Pull it in the front. Now, this part that I boxed does look just like number 3. So I can take that 4 and multiply by, what can I do here? That's gonna be 5 what? Squared, isn't it? Now do order of operations. Do you multiply first or do powers? Powers. So I'm gonna have 4 times 25, which gives me what? Everybody okay? Question.
Can you also justify pulling that 4 in front because of number 1?
No, now we're gonna get to one in a minute that's a product, then you
That's
can
what
use number
okay.
one. That's right, that's right. When we get back there, you can do it multiple ways. Okay, so is everybody okay so far? Now, the reason I keep having to stay on this board, they cleaned these rooms really good over the weekend and bombed them and messed up all the technology, so I can't move the camera. All right, so I got to stay on this board, but you got these in your notes, right? All right. Now, what if you've got a sum? You can split it up and do it like this. Now again, it gives me permission to change the order. Do you understand? On the left side, I've got to add the functions first and then take the limit. But on the right side, this is I can take the limit first and then add. So this says the limit of a sum is the same thing as the sum of the limits. So what if I had a problem like this? What's the limit of x plus 3 as x approaches 1? All right, are we okay that I'm going to separate these? One of my functions is x. What's my other function? 3. So I'm going to do it the limit of x as x approaches 1 plus the limit of 3 as x approaches 1. Now, look at your notes because my boards are raised. To work this first part, the limit of x approaches 1, which rule is that we just went over? Isn't that 2? So what's the answer to this first one? On this function, when x is getting close to 1, what's your y getting close to? 1. All right, which one is this one? In that rule 1, the limit of a constant is the what? Constant. So I get Now, the lovely thing is it doesn't just work for plus, it also works for minus. So do you understand if this had been a minus, I still wouldn't have been able to separate them. But this time x would come out to be a negative what? 2. So if you've got a sum or a difference, you can separate them. All right, similarly, what if you have a product? Okay. What's the limit of f of x times g of x as x approaches? Well, again, I'm going to be able to separate them like I did with sums and differences. That's going to be the limit of the first one times the limit of the second one. So that's kind of what Drew was just talking about a second ago. I remember what we had here, like a 5 or something. Instead of taking that 4 and pulling it out, could I look at that as 4 times x squared? So I could look at it as the limit of the first one times the limit of the second one. I could look at it as a product. What's the limit of a constant no matter what you're approaching? It's that what? Isn't that constant? And then again, the limit of x squared as x approaches 5 is 5 squared, so I'm still going to get 100, just like I got 100 a minute ago. And then it also works with a quotient. That would be the limit of the numerator divided by the limit of the denominator. All right. So that would be something like the limit of 2x over 7 as x approaches 3. So I could do it as the limit of the numerator over the limit of the what? Denominator. Now I'm going to change something for a second. I'm going to go back and work this in a minute. I'm going to put an x there just to make a point. Then I'll go back and work it the way I had it. What would if I just had x, what would the answer to the numerator be? Wouldn't it be 3? What would the answer to the denominator be? It would be what? 7. Is everybody okay? Then I've only got to use that rule. I'm going to go back and change it to 2x over 7 to show you something. Now I've got to use more rules. Because if it's a 2x, I'm going to have to use a different rule to work that one. Is everybody with me? I can either take that number and do what? Pull it in front. Or I can think of that as the limit of 2 times the limit of what? X. It'd be whichever way you saw it. Which way would y'all see it? Like, would you take the 2 and pull it in front, or would you do the limit of the 2 times the limit of the x? All right. Limit of 2. Limit of x. Limit of 7. What's the limit of a constant? Is that constant? The limit of x, x approaches 3 is 3, and the limit of a constant still the constant. So I get 6 what? 7. Okay. So we're going to work on those rules over and over and over and play with them some more. So some of your homework is going to be to do some expansions with these long properties and to do a couple of proofs. Okay. And then next time we'll get some shortcuts so we don't have to do them so long. Because otherwise, see, if I gave you one like this for tonight, and said do this. That's going to have several steps. Because I'm going to do the difference first and do the limit of the first one minus the limit of the second one. Now this one I can already work. That's the very first rule we went over. Now this one depends on how you see it. It may be the second rule where I can take that number, the fourth rule, take that number and do what? Pull it out. Now this one looks just like that third rule we went over, which says that's 2 squared. And this one looks just like that first rule we went over, which says 4. So I'm going to have 4 times 6 is 24 minus 4 and finally get what? So you got to use all your rules. Everybody okay? All right, now you're about to have a pop test. Where's your homework going to be though? On Moodle. All right, so a clean sheet of paper. When you finish, You're gonna fold it lengthwise. And put your name on the outside and just put it on the table and you kind of go out. Two little problems. You find the F composed of G at a -1, and then you find me the domain of you'll have a pop test pretty regularly. So like that one, it'll never be on what you had the class right before because that might be still sticky for you.